Welcome to the tutorial for the MPLAB starter kit for PIC18F. My name is Marius Voicu and I'm an application engineer at Microchip Technology. In this tutorial, I'll be guiding you through the PIC18F starter kit's hardware and software, and showing you the powerful features of the PIC18F G series flash microcontrollers that can be utilized in your own application. In this webinar, we will discuss the hardware features of the PIC18F starter kit, the features available on the PIC18F46J50 family devices, and discuss the demos that are included with this kit. The starter kit consists of the software installation disk, the starter kit board, a mini USB cable to connect the starter kit to the PC, and the microSD memory card with the pre-compiled demo applications. Before connecting the starter kit to the PC, install the starter kit software by inserting the CD and following the instructions. The installer program will install the MPLAB IDE, a student version of the MPLAB C18C compiler, the bootloader, the demo applications, and the starter kit documentation. Let's take a look at the starter kit board. Note the white rectangular on the bottom of the board. The circuit inside of this rectangular is an in-circuit debugger. This allows us to debug an application on the starter kit without the need of an external debugger. The circuit outside of the white rectangle is the demonstration application. PIC18F46J50. At the heart of the application is a PIC18F46J50, a 44-pin member of the PIC18F G family flash microcontroller family with USB capability. The microcontroller features 64 kilobytes of flash memory and 3776 bytes of RAM. Capacitive touch buttons and scroll bar. The 4-element keypad is an integral part of the board's top layer. The application responds to capacitive changes induced by direct contact with the user by monitoring each of the touchpad's elements with the microcontroller's integrated CTMU module. OLED display. An 128 by 64 pixel monochrome organic LED array provides a wide range of graphics and alphanumeric display options. 3-axis acceleration sensor. This digital sensor measures the acceleration of all the 3 axes and can be used in different applications to determine the tilt of the board, which can be used, for example, to control the movement of the cursor in a USB mouse demo. Menu button. This switch can be used at any time within the demo applications to load the bootloader menu. MicroSD memory card. MicroSD memory card provides storage space for pre-compiled application files. The bootloader can load applications from the microSD card and program them to the microprocessor flash memory. Potentiometer provides an analog input to the microcontroller for certain demo applications. Mini B USB receptacle provides system power and bidirectional communication between the host PC and the starter kit. PIC18F microcontrollers have many features and peripherals that makes them powerful, versatile platforms for embedded projects. Let's discuss the features that are available on the PIC18F46J50 family devices, the device that is included on this board. The Parallel Master Port, or PMP, is a parallel 8-bit I/O module specially designed to communicate with a wide variety of parallel devices such as communication peripherals, LCDs, external memories devices, and microcontrollers. Because the interface to the parallel peripherals varies slightly, the PMP module is highly configurable. The real-time clock and calendar module is a 100-year clock and calendar with automatic leap year detection. It runs off a 32 kHz input from the secondary oscillator and is optimized for low power usage in battery-powered applications. The Universal Serial Bus module contains the analog and digital components to provide a USB 2.0 full speed and low speed device implementation with a maximum of external components. USB device support allows an application to easily interface to a computer. The charge time measurement unit is a flexible analog module that provides accurate differential time measurement between pulse sources as well as asynchronous pulse generation. The CTMU allows an application like the starter kit to utilize capacitive touch sensors for the user input. PIC18F46J50 microcontroller has two MSSP modules that can be configured for either I2C or SPI communication with other peripheral or microcontroller devices. These peripheral devices include digital sensors, serial memories, shift registers, display drivers, and AD converters. The accelerometer and the microSD card are both utilizing the same SPI bus. PIC18F46J50 microcontroller has two enhanced capture and compare PVM modules. These modules contain a 16-bit register which can operate as a 16-bit capture register, a 60-bit compare register, or a PVM master-slave duty cycle register. The 10-bit analog to digital converter allows conversion of an analog input signal to a corresponding 10-bit digital number with auto-acquisition capability and self-calibration. On the starter kit, the analog channel 0 to channel 3 are used together with the CTMU for the capacitive touch buttons and scroll bar, while the analog channel 4 is used for the potentiometer. Two enhanced USART modules with auto wake up on start bit that supports RS485, RS232, and LIN J2602. The major challenge in a general purpose device is providing the largest possible set of peripheral features while minimizing the conflict of features on I/O pins. Peripheral pin select also allows peripherals to overlay each other. For example, mapping an interrupt on change input into a UART receive pin allows the device to wake up from sleep when the character is received. In addition, peripheral pin select allows multiple pins to be used for a single output function, increasing the drive strength. In this demo, the peripheral pin select is used to multiplex the SPI communication line with the PMP communication lines, allowing for flexible usage of the I/O pins available on the part. Now that we have discussed what is on the board and what features are available on the PIC18F46J50 product family, let's discuss how to use the PIC18F starter kit. Once the starter kit software is installed, connect the provided USB cable A to Mini B to any available USB port on the PC or powered hub, then to the starter kit at the Mini B receptacle on the application side of the board. The PC USB communication provides communication and power to the board. A microSD memory card used to store the demo applications may be connected to the starter kit at any time. If the cable is connected correctly, the green power T3 is lit. The OLED will display Microchip PIC18F starter kit startup menu, and the application processor will wait for the menu button to be pressed in order to load the microSD bootloader. The PIC18F starter kit is built around a microSD card bootloader. This bootloader allows multiple demos to be loaded into the SD card and loaded into the microcontroller when they are selected from the bootloader menu. The flash program memory of the Microchip's PIC18F46J50 device is readable, writable, and erasable during normal operation over the entire VDD range. This feature gives the user the ability to perform bootloading operations. To demonstrate this feature, the MPLAB starter kit for PIC18F comes with a pre-programmed microSD card bootloader that gives the ability to load, program, and run PIC18 applications from a microSD card. The microSD bootloader accepts user inputs from the capacitive touch buttons and scroll bar and uses the OLED display for user outputs. The microSD bootloader uses a substantial part of the microchip memory disk drive file system to read files and folders from a microSD memory card. When the board is powered, an welcome screen is displayed and the board waits for the menu button to be pressed in order to load the bootloader. If the counter reaches 0, the last program application will be loaded. A microSD memory card can be inserted at any time. When it will be detected by the microSD bootloader, the MDD file system will be initialized and the file structure will be displayed on the OLED. Please note that only folders and hex files will be displayed. The user can press the up and down buttons to select a specific file or folder. If the accept button will be pressed when a folder is selected, the microSD bootloader will display on the OLED the content of that specific folder. To return one level up, the user can either press the cancel button or can use the accept button when the ... folder is selected. If the accept button is pressed when a hex file is selected, the microSD bootloader will prompt the user for a confirmation to load the file from the microSD memory card and to program it to the microcontroller's flash memory. After this operation is finished, the user may choose to execute that application or to remain in the bootloader. If the cancel button is pressed in the root directory, the microSD bootloader will exit and the last programmed application will be executed. There are several pre-compiled demos that come loaded on the microSD card ready for testing on the PIC18F starter kit. These include a mouse demo using the accelerometer, a joystick demo again using the accelerometer, a custom human interface device application that allows custom application data to be sent over the bus, a CDC demo that allows the board to appear like a serial port to the computer, and a mass storage demo that allows the board to appear like a disk drive on the computer. In this demo, the board will act like a USB mouse using the accelerometer as a tilt sensor. Hold the board flat relative to the ground for no movement. If you have difficulty finding the mouse cursor on the screen, or if you keep losing it, please make sure that the board is flat relative to the ground. Tilt the board to move the cursor. Press the L button to left click and R button to right click. Hold the menu button to return to the demo menu and to load a different application. In this demo, will act like a USB joystick. Tilt the board to move the joystick on the X or Y axis, use the scroll bar to move it on the Z axis, use the potentiometer to rotate around the Z axis, touch the L and R capacitive pads to control the first and second buttons. A test program is included in the application folder for the joystick demo that allows testing of the joystick features. The game controllers option from the Microsoft Windows control panel can also be used to show the joystick behavior. Hold the menu button to return to the demo menu and to load a different application. In this demo, the board will act like a USB custom HID device. Connect the board to the host computer and run the HID PNP demo exe provided on a CD-ROM disk. The PC application is reading the raw data from the capacitive pads, acceleration sensor, and potentiometer. To demonstrate the bidirectional communication, the mTouch Calibrate button on the user interface is triggering the calibration routine of the mTouch library on the PIC18 starter kit. Hold the menu button to return to the demo menu and to load a different application. In this demo, the board will act like a USB communication device. When this demo application is connected for the first time to a host computer, it will ask for an INF file. In this case, point to the INF file provided on a CD-ROM disk in the CDC demo folder. After complete enumeration, the board will appear like a serial port on the host computer and will start sending the raw data from the acceleration sensor. use your preferred hyperterminal software and connect to the port COM created by the board to see the data. Hold the menu button to return to the demo menu and to load a different application. In this demo, the board will act like a USB mass storage device. Insert a microSD memory card and connect the board to the host computer. Files can be read, deleted, and manipulated like any other drives on the computer. Hold the menu button to return to the demo menu and to load a different application. Next, we will see what resources are available for feature study. When you are ready to try your own application or simply modify the demonstration project, refer to the Starter Kit user guide, which is installed in the Starter Kit documentation directory. You can also refer to the extensive online help available for MPLAB IDE and the MPLAB C18C compiler. Go to the Microchip website www.microchip.com for the full, most recent version of the libraries and application notes used in this demonstration. You can also find the appropriate datasheet and family reference manual chapter at this site. For more information about USB library, go to www.microchip.com/USB. Thank you for taking your time viewing this webinar. We hope you found it useful and would love to hear any comments, suggestions, and requests that you have.